Okay, well, my watch says 3 o'clock, so we're going to go ahead and get started. Thank you, everybody, for coming today. We're going to be talking about building and running ASP.NET application in Habitat. So we're going to be looking at what does Habitat feel like in Windows? What does a Habitat supervisor look like on Windows? What does a Habitat Studio look like on Windows? And in particular, we'll be looking at an ASP.NET application that's full framework, not .NET Core. We'll be working with IIS, and we'll be working with SQL Server. So we'll actually have a packaged version of SQL Server installed and running under a Habitat supervisor. So, and we'll export them to containers. And they will talk to one another and enjoy each other's company. So I work for Chef. I am a software developer on the Habitat team. I've done other things, but really my main responsibility, my main role on the Habitat team has been to make Habitat work on Windows. And really, I hope that I can make Habitat and that we can all make Habitat shine on Windows. So essentially what that means is anything that has to do with users, file systems, or processes, we have to do different stuff, interact with Win32 APIs, and sometimes fundamentally different abstractions. The Studio and the build system are complete shell implementations. So that means on Bash, on Linux, they're Bash implementations, and on Windows, they're PowerShell. So it's very much my job to make sure that that is a great experience for everyone. Let's see. Okay, here we go. So real quick, before I dive in, I just want to drop a few URLs on you because I'm going to be going through a lot of content and be going through this fairly quickly. So Habitat, our website is www.habitat.sh. So if there's stuff that I kind of race through or you want to dive in some more, that's where you're going to find our documentations, our tutorials, and also our hosted builder service, which I'm sure you'll be hearing about this week. The ASP.NET plan that we're going to be building here, we'll be going into pretty good detail, but not line by line. So if you actually want to look at that more deeply and even build it and run it yourself, this GitHub repo is where you'll find it. If you want to run Habitat as a Windows service, which is how we recommend you run it in production, go to this repository. That will have a README that gives you basically the few steps that you need to actually set that up and create the Windows service and configure it and get that running. And then lastly, there's a plan that we're not going to look at this plan, but we are going to use this plan. But you may find this plan interesting. It's the SQL Server plan. It's in our core plans repository. So you may be interested to give that a look in case you want to see how it actually works. So the first thing that we want to talk about when we talk about running Habitat on Windows is how do you get Habitat on Windows? So you could obviously go to the Habitat website and grab our binaries. But I personally find that the easiest way is to use Chocolatey. All of our distributions, as part of our release process, we release out to the Chocolatey community feed. So a Choco install Habitat will install the Habitat CLI and everything that you need to run a Habitat supervisor on your local system. So this is really where we are going to leave the slides. I will post the slides. You and others can look at them later, but I think it's going to be more interesting for us to actually look at real code and stuff. So let's do that. So the first thing that we want to talk about when we talk about really Habitat anywhere is a plan, right? So the plan is the basic building block of a Habitat package. Now, what differentiates a Habitat plan on Windows from Linux is that on Windows they're written in PowerShell. And that goes for the hooks too. So the hooks, those are the scripts that the supervisor will run at runtime. Those are also written in PowerShell when you're targeting when you're targeting Windows. Now, for those of you who are familiar with Linux-style bash plans, and you're looking at this plan, it shouldn't look that different, and that's actually by design. We want them to be similar. We have the same structure. We have the exact same plan settings, so all of those settings are the exact same variable names. The key difference is this is PowerShell. This is PowerShell syntax. Those arrays are PowerShell arrays. They're not bash arrays. We've got PowerShell dictionary, hash table. They're not associative bash arrays. And then down at the bottom, these are true PowerShell functions. And so what we're going to do in this plan is we are going to, basically we're going to download an ASP.NET website from the Microsoft Code Sample site. Because what I want to show to you is everything that we're going to do today is I'm just using just a generic ASP.NET code out there. I'm not making any changes to it. There's nothing funky going on behind the scenes here. So this is the entity framework sample application that we're going to be working with. That particular application just makes it easy to demo with SQL Server because it actually creates the database and creates the schema for us. So it makes for a nice demo app. So we're going to download the source code from the code sample site. And then down at the bottom, we're going to do our build. Now, anybody here who is familiar with building ASP.NET applications or any .NET application should find this familiar. We're going to use two tools. We're going to use NuGet and we're going to use MS Build. And so we can use NuGet because we've declared a build time dependency on the core/NuGet package. So we've packaged NuGet, the NuGet exe, by virtue of declaring this dependency on it. It's going to be on our path so that anywhere in our plan we can just call out to it just like any other tool. So first I'm going to do a NuGet restore, which is going to pull down all of my dependent .NET assemblies. Then I'm going to install this particular MS Build target. What this is going to allow us to do is this will allow us basically to build an ASP.NET web project on a server without actually having Visual Studio installed. And that's because we definitely want to not have to download and install Visual Studio on our server. And then a couple lines down, I'm going to actually use MS Build. So here I just go to the MS Build that just comes with .NET, which will be on your operating system. And I'm going to point it to my CSproj file. So those familiar with .NET that should look familiar. And then I'm going to use the build target. So that's going to take all my C# code and that's going to compile it into a .NET assembly, my DLL file. And then lastly, I'm going to call my invoke-install function. This is the function that installs our application into a Habitat package. So again, I'm going to use MS Build. This time I'm going to use a different target. This time I use MS Build's WebPublish Target. The WebPublish Target, what that basically does is that will take every single file that's needed to actually serve out our website, that's needed to be consumed by a web server, in our case by IIS, and basically plop it on disk to wherever it is we tell it to. We're going to tell it to publish it to this variable. This is a variable that's defined in the Habitat build process package prefix. It's essentially the Habitat package staging area. So anything that we copy to this particular directory is going to be included into our final Habitat package. So that's all great. That's our plan. So once this is built, we will have a package that contains all of our ASP.NET code, all of our HTML, CSS, our DLLs. But you might be wondering, well, then what? Anybody that deals with IIS, for example, knows you don't just plop down a directory and expect things to work. You have to tell IIS where it is. If you looked at these dependencies, there's no dependencies here for IIS. Heck, there's no dependencies for the .NET framework. What's going on here? Yeah, if this was a Java app, or if this was a Node or Ruby app, even if this was a .NET Core app, we would have a dependency on one of those runtimes because typically they expose to us a nice binary that we can call from anywhere on disk, point it to our application, and it will know what to do from there. The .NET Full Framework is not like that. The .NET Full Framework wants very much to live in a very specific place on your file system, in your root drive, under Windows, the Microsoft.NET directory. It is not easily transported elsewhere on disk. On top of that, you've got the global assembly cache. Those that are familiar with .NET. So that's, again, that's got to be one place. There's no multi-apartment model or multi-tenant model for the global assembly cache. And then you've got the registry settings. So the thing with the .NET framework is it doesn't really make for a great habitat package. So this is what we've done with the .NET framework, or what we've kind of decided to do, and that is basically to treat the .NET framework as a piece of infrastructure. And what I mean by that is essentially leave it as a responsibility of our provisioning or our configuration management layer to lay down the particular version of the .NET framework that we expect to be there. Then, so by the time you start up the Habitat Supervisor and load up your application, essentially your Habitat package will assume that the .NET framework that it needs is present. Now, if you're like me, the word assume is a uncomfortable word, especially when it comes to like this type of stuff, because your assumptions better be true. So that all said, these assumptions are not totally unfounded. So when you install the Windows operating system, any version of the Windows operating system that Habitat supports, and that is 2008 R2 and Windows 7 on forward, you will have a version of the .NET framework on your system. That's by default. You will always have that. Now, 2008 R2, Windows 7, you'll have an older version. You'll have like the .NET, you'll have the 2.0 CLR. However, if you fully patch even those older versions with all of the critical patches from Microsoft's Windows Update Server, you will get the 4.0 CLR, so today's CLR. You may not have the latest .NET 4.7 runtime if your application requires that. It will be up to you to install that. But for example, on this particular application, we just need .NET 4.5, which comes with modern versions of the Windows operating system, so we're not going to have to do anything as far as the .NET framework goes. But that's how we deal with the .NET framework. So then there's IIS. So again, if this was running under Nginx or Apache or Tomcat, we would declare that as a dependency. Those servers, provide to us a nice executable. Also, we can build up a configuration file, point those servers to that configuration file that tells them about our application, and everything just works. Doesn't matter where we call it from. They make for great Habitat packages. IIS is different because IIS is literally baked into the Windows operating system. So it's actually a feature of the operating system. It may be asleep, may not be enabled, but it's there. It's not, we don't just go off somewhere and download the IIS binaries and install them. So this is how we deal with IIS. And when I say we, I mean in this particular plan, this is how I have chosen to deal with IIS. You're free to do this however you want, but we basically leverage DSC, so desired state configuration. There are other ways, so you could use older tools like AppCMD or some other PowerShell modules, but DSC is clearly the most elegant tool available. So that's what I'm going to walk you through here today. So if we look in our configuration directory, we have a file called website.ps1, and in this is basically a DSC configuration. So this is going to set up our web application pool. It's going to set up our website. It's going to set up an application folder. This is all a template because it's in our configuration directory. We can use all of the Habitat handlebars templating. So this will swap in the name of the site that we have configured. It'll swap in the port that we have configured for this to run in. The place on the place on disk where our code will actually sit. So by the time that this DSC configuration is applied, I expect to have, and we actually enable ASP.NET as well. And what that'll do, that'll enable ASP.NET as well as all of its dependencies. So that means if the IIS role is not enabled, it will enable that too. So once this DSC configuration is applied, I should have everything on my machine enabled, configured, and actually turned on. So it'll start the application pool, it'll start the website, and I should be able to hit my website in a browser. So how does that actually get applied? So here's our configuration. How do we actually make that configuration do its thing? So what we've basically done in this particular plan is I'm presenting to you basically a plan authoring pattern, and so which leverages DSC. And so to go to the beginning of that pattern is we're going to look back at our plan, and we're going to look at this runtime dependency. So we're declaring a dependency on a package called DSC-core. And DSC-core is a PowerShell module I wrote that basically makes it easy to apply a DSC configuration in PowerShell core. So let me pause right there and talk. We'll kind of hop off onto another subject real quick, because I said PowerShell core, and that has some ramifications. So the plans and the hooks that PowerShell, or excuse me, that Habitat will invoke, it will invoke using PowerShell core. PowerShell core is different from Windows PowerShell. Windows PowerShell is the version of PowerShell that shipped with your version of Windows. So that could be PowerShell 2, PowerShell 4, the latest is PowerShell 5.1. PowerShell core is the open source version of PowerShell that you can find on GitHub that's maintained by the core PowerShell team. We can contribute to it. We have contributed to it, and our contributions are now in what's released today as PowerShell core. But most importantly, what using PowerShell core does for us is allows us to build it on our own and to package it with Habitat, and therefore level set PowerShell functionality. I don't have, as you know, when we're going in and we're writing the Habitat build system, we don't have to have all this funky code that says, well, gee, am I on PowerShell 2 or am I on PowerShell 5? Because whether or not I'm on one of those, I'm going to have very different code and have much different functionality available to me. So I know exactly what commands are available to me. I know the syntax and the idiosyncrasies of that is present. I can also much more easily write documentation, blog posts, sample plans, and not have to specify, well, if you're on this version, I know exactly what version of PowerShell is being run in our runtime. There is a catch to all this, and that is there are a few subset of commands that are not available on PowerShell core. So one of them is the ability to apply a DSC configuration. You got a nice one-liner in Windows PowerShell. So this particular package, this DSC-core package, basically kind of hides the goo from you that you have to do to get that working in PowerShell core. So now that we've actually declared a dependency on that package, what we can do in our run hook, so we'll go down here to lines 16 and 17, is we import. So first we're going to import the module. So we use our Habitat templating helper here, package path 4, to find the directory where that package is located. And then once we found that directory, we know that in our modules/DSC core directory, that's where the PowerShell module is. So we import that. By doing that, we now have start-DSC core available to us. That's the function that I wrote inside that package. We point it to the website.ps1 we were just looking at. Again, because this is a template, I know that that's going to, at runtime, the service config path is where the supervisor is going to put that file. And we call the actual DSC configuration name, which if we look at it, we can see it is new website. So that's how all that gets called out. But if you are worried, oh my gosh, you're running PowerShell core, how will I know if maybe I need to use this particular module and it's only available on Windows PowerShell? Well, here's the trick. This is what you do. This particular script block is going to be run inside the context of Windows PowerShell because I used invoke command. So if you have script that you know needs to run inside of Windows PowerShell, this is how you do it. You use invoke command, which essentially leverages PowerShell remoting. But the funny thing is, maybe it's not funny, I find it funny, but computer name is localhost. So we're basically remoting out to ourselves. I guess you could look at it, you're remoting out of PowerShell core and into Windows PowerShell, so out of process. But you're not crossing any machine boundary. So that's how that works. There's more that we could look at this plan, at these hooks, but at this point, what we're going to do is we're going to actually look at, we're going to go to a studio. So this is a studio on Windows. Now, for those of you that are familiar with running studios off of your Mac, maybe, or maybe you're on Windows and you've used the Linux Studio. So we do a lot of this, the same thing that we do in those contexts. We leverage a container. And so basically here we get that same environment where we have as minimal OS as possible. And so there's nothing installed, and particular to Windows, there's nothing in our registry, at least nothing beyond what you would get with a clean Windows install. And you just have, beyond that OS, you just have the Habitat build system, and you have a Habitat supervisor running in the background. So I could say get service Habitat, and there it is. So, and it is running. And I could even go deeper. I could say, use the power of history. What services do I have run? So I did cheat a little bit. I opened this up before this talk, and I ran hab service load core/SQL Server because our application is going to need to talk to a database in order to be of any value to us. Just to point out, so the SQL Server plan, unless you tell it otherwise, and you can tell it otherwise, but unless you do, it's going to install and run SQL Server Express, which is basically the free version of SQL Server. You probably wouldn't want to run that ever in production, but it's fine in a studio. Now, if you have your own install media, perhaps you have SQL Server Enterprise, you could point it to that, it would install that, it would run it under its supervisor, you share configuration management or configuration data with it, and that will work great. But for our purposes, we'll just stick with SQL Server Express. Now, one thing to note too, so I have, this is a container, so I'm in a Windows Server core container, and so if we look at my Docker context menu, and I can just tell you right now, you're not going to be able to read this, but so I'll tell you what it says, at least in the back, unless you have exceptional eyesight. So this says switch to Linux containers. So basically you can toggle back and forth between Linux containers and Windows containers. So when you type hab studio enter in a console, the mode that you're in here is going to determine what type of studio you're going to enter into. So if you're in Windows container mode, like I am now, you're going to end up in a Windows-based Habitat Studio. If you're in Linux container mode, you're going to end up in a Linux-based Habitat Studio. So just that's something to be aware of. So the other thing, and this is just, this is true of all of the Habitat Studios, the directory from which I entered the studio was mounted into this source directory, which is where I am now. So if I do a dir, I can see I'm now at the root of my, my plan directory. So there's my plan.ps1, my hooks, and my config. So now I'm going to build it. And so this is now running that plan.ps1. It's going out to the code sample site, downloading it. It just went out to NuGet, pulled down all my .NET assembly dependencies. It's about to compile all my C#. Now it is about to lay out all my files into my package staging area. Now it's actually generating the package in about 2 seconds. I'm actually going to, see, I bet you that was 2 seconds. It's going to actually, so I have my heart file, and not only that, just like any Habitat Studio, it also installed this heart file into my local studio Habitat environment. So I can actually run this. So let me do that. If I can see. Okay, I know my cursor is somewhere here. Let me just clear the screen. Okay, so I'm going to do, come on, history. There we go. So I'm going to load my service, so mrock, so Contoso University, the signature Microsoft sample site. -- bind, I'm going to bind to SQL Server. We've already seen that SQL Server is already running. Don't get a whole lot of output because the supervisor is actually running in the background. So I can't see right now, I can't see standard output from the supervisor. I just get a nice message saying my service was loaded. However, I can type get supervisor log and get that output. So now it's compiling the DSC moff. As soon as it's done with that, it's going to actually apply that DSC, and then my website will be up and running and I can actually hit it. So how do I do that? So here's another area where Linux containers and Windows containers differ a bit. So Windows containers do not really deal with the loopback adapter like Linux containers do. So for example, even if I've forwarded port 8099, which is the port that this application is running on, I can't just go to localhost 8099. I actually have to go directly to the IP address of this container. But fear not, I have that IP address. But even if I didn't, it's actually a pretty straightforward act. So in fact, I did it up here. So so here is the results of a Docker PS. So I have 3 containers currently running on this system. The one I'm concerned with now is this top one, and that is the Windows Studio container. I've got the container ID, and basically, so up here, what I did was I just did a Docker inspect and basically told it, just show me the IPv4 address of this ID, and I got back this particular IP address. But that's not very interesting. Let's actually look at that. Well, that was 31, yeah, so this is this one. So I'm going to refresh this because I expect that to bring up my site. And so there we go. So this is it. I'm now hitting the site that my studio just built. I don't have any data here, but I know that it actually did a listing of the database. So it actually hit the database. There's no data in my database. So I would have the yellow screen of death right here if that database, if that binding was unsuccessful. Well, in Habitat land, if that binding was unsuccessful, I wouldn't have even gotten this far because it won't even run your application. But at any rate, I'm happy. I'm satisfied. What I see in the studio is great. I'm ready now to create a real Docker image out of my my application. So I've already done that because we don't have all day here. And so what I have here at the top, so I did a HAB package export. So it's the exact same thing. So I guess if you walk away with anything here, I want you to, one of the things I want to get across is that there's no fundamental difference between Habitat on Windows and Habitat on Linux in terms of the command line. All the same, you've got all the same stuff available to you. So I did a HAB package export Docker. So I'm exporting my package in the Docker format. And then I give it the path to my heart file. And so what happens when I do that is, very similar thing to what happens with a Linux-based package. We start off with a base image, but rather than the scratch Linux image, we use instead the Windows Server Core image. After that Windows Server Core image, we layer on top of that the Habitat supervisor and launcher. So basically the bits that Habitat needs to be Habitat and to run Habitat packages. And then so on top of that, we add our package, the application we built, and then any runtime dependencies that it has, and any of their runtime dependencies and so forth. So the entire dependency tree gets built into my image. So at the end of the day, I have an image with a fully runnable version of my application. So on this system, I have already exported also the SQL Server plan. So I have an image for SQL Server, and I have an image for my application. I've taken the liberty to already launch those containers. But I guess what I will show you, just so that you can, just for the sake of demonstration here. Okay, so so when I launched the SQL Server container, I just did a Docker run -it SQL Server. But this one I have to do a little bit more work. So here I do a Docker run. I give it my my image name, which just so happens to be and will always be in Habitat the name of my origin / my package name. And then any argument after that gets forwarded on to to the supervisor. So here we see the same bind that we saw before. I need to bind to SQL Server, but unless I have this peer address, there's not going to be any SQL Server, right? Because I've got a container, I've got my application in the container, and that's it. There's no SQL Server. So I just so happen to know the IP address of SQL Server. That IP address is this, and so what this does is this allows the supervisor that I'm running my application in to find the supervisor that exists on this IP address. They find each other, they make friends, and they share information amongst themselves. And included in that information is the fact that indeed there is a SQL Server running on that other supervisor, and they can, and now my application can correctly form its connection string and connect to that IP address and has the, get the credentials and the port and everything that it needs to hook up to that SQL Server. So I want to now, so I've already got these things running. So Docker PS is, here's the output again. So there's 3 containers. There's my studio. This is my actual application. I know it's a funky ID, but trust me, that's the Contoso University application, and this is SQL Server. So I want the IP address of this guy. I could do the exact same thing that I did before, but I actually have this, so I'm just going to refresh this, because this is the IP address, this .43 IP address. So I refresh it, it comes back. This one actually has data because I've been playing with it and been entering some great students into my database. So this is 2 Windows containers built by Habitat, one running SQL Server, the other running ASP.NET. And that is the bulk of what I want to show. I want to leave some time for questions. There is actually more detail and caveats I could share with you, but what I'm going to do is I'm going to take some questions first, and then if we have any other time, I'll throw out some more tidbits. But how do you handle Windows features that require a reboot? That's a great question, and so there's a couple ways to approach that. One way is, again, so think about like, what would it be that would require a reboot? Oftentimes it's like joining a domain, right? And so something like joining a domain, like I would say do in your provisioning. Yeah, thanks so much for coming, really appreciate it.